Okay, last day of new notes. In case someone's watching this later, make sure you do the Schoology quiz by tonight. And again, the rules are do it until you get them all right, and then you get 7 points on the test. Okay, example 2. No calculator still. The velocity of the particle is given by this thing, v is in meters per second. Find the acceleration of the particle at time equals 2. So they give me velocity, they ask for acceleration. How do I find it? Like just generically, not for this particular problem. It's the derivative. Some people, they'll write that down on their page. SVA. Take a derivative to go down the page. Take an integral to go up the page, but we don't know about those yet. So derivative of S is velocity, derivative of velocity is acceleration, and then there's also that second derivative thing to get from S to A. So concavity and all those ideas. Okay, so I need the derivative of this guy. Oh, product rule. Okay. First times derivative of the second. Derivative of, let's just put some people on the spot here, Lexi. How about the derivative of the natural log of t squared?
2t over t squared.
Very nice. 2t over t squared. Obviously, there's some cleanup work to do there with canceling t's, but first times derivative of the second plus second times derivative of the first. Do I pull a popsicle stick for derivative of the first? Give somebody what I think is an easy one. Dylan, how about the derivative of t? 1. So this acceleration would be, the t's would all cancel in this first part, 2 plus natural log of t squared. Looking at my notes, I didn't do something that I've told y'all to do before. I didn't write that that's v prime. So it's not wrong, and if it's a short answer question or a multiple choice question, then fine, no big deal. But if it's a free response question, then I would need to say that I'm taking the derivative of v to get acceleration. I guess if I had this on the page, that might qualify as showing the work there. At time 2, so now I'm just going to plug in 2 plus natural log of 2 squared. This is one, I hate when we do this to you, but you've got to know, you have to recognize answers here. That would be the same thing as 2 plus 2 natural log 2, because you could take that exponent and move it down front. Or you could just square the 2 and say 2 plus natural log 4. So be careful. There's the safe stop, but if it's multiple choice, they might simplify it a couple different ways. And when they simplify it using that property of logs, I hate when they do that, because that means you missed the problem because you didn't know a property of logs, not because you didn't know derivatives. Okay, with calculator, nothing new except that we get to use a calculator, so usually you get uglier equations to deal with. So I'm going to press pause, and then you can... Calculators are a help. They're not the fountain of all wisdom, right? You have to know what you're doing with your calculator, and you have to tell me what you're doing with your calculator. It can do some amazing things. It can do some things that you're going to learn about in a minute. And you're like, wow, why didn't we do that at the beginning of the year and made this process a whole lot easier? Well, yeah, but then the calculator would be doing it rather than you doing it. So, yes, use your calculator, but you've got to constantly be showing what you're doing so that I know that you know what's going on. You just didn't write something down off the calculator. All right, the velocity of a particle is given by this ugly-looking thing. I suppose we could do that by hand if we really needed to, like a derivative, because it would be product rule and then chain rule and quotient rule. Ugh. Find the acceleration of the particle at time 2. So how do I find the acceleration? V prime at, in this case, 2. Okay, here's the fun part. Couple ways to do this. I'm gonna almost always put those long equations in as equations, and then we can use them after that. I'll show you a different way later, but I think it's easier just type them in as equations. So sine of fraction bar x cubed over 1 minus x times cosine of the natural log of x squared. All right, now, so I don't lose track, and because later on we may have more than one equation, I'm going to just label that y1 so that anytime I want to use v, if I mistakenly call it y1, it won't be a mistake anymore because I've told the grader what y1 is. Now, I'm going to double check that I got that in there correctly. X cubed over 1 minus x cosine of the natural log of x squared. Okay. Now I would like to take a derivative of that at 2. Here comes the fun part. So back on the main screen, let's go to, so on the calculator, go to math. So I'll write down the steps and then do the steps. There's a button for math. Scroll down until you see something that you think would be helpful in finding a derivative. Yeah, in derivative. That looks a little funny. It's written funny, but it's in derivative. So it's math 8, math option 8. You press enter, and then several years ago they did a software update where it makes it look like what you want it to look like. So I'm taking the derivative with respect to something, the derivative of something with respect to something, and then remember that bar means at something. So I'm going to take a derivative with respect to x, since that's the variable I used. What do I want to take the derivative of? y1. Do you know how to get y1? Look at your buttons. Any button look like it might have y1 hidden in there somewhere? What's y1? y1 is a variable. So let's go to vars. And then yvars. A lot of buttons. And then we want a function, and there finally is y1. So where did we do that? So that was vars. Okay, so where do we go after vars? Let's back up and do it again. Vars, yvars, because we want a y variable. And then we want it's a function, it's not parametric or polar. And then we can get y1. So I want the derivative of y1 at what point? 2. So there's my answer.
So do we have to like I don't understand what we're writing here.
What you're writing on the paper is just that. because we know that the calculator can find a derivative. So if you tell me, as long as you tell me like that v prime step, that's got to be in there. Because I know the calculator can do it, but I need to know what you're asking the calculator to do.
Is day 1 calculated or day 2?
Day 1 is with calculator. Day 1 is with calculator. Okay. Kelsey, what did you say a minute ago? So if you look at it on the graph, oh yuck. I'm going to make sure I'm in, since I've got sines and cosines, always in radians in here. Always, always, always in radians. So you don't have to worry about in radians graph. So second calc, dy dx. And then it asks you, well, where do you want? You can just type in 2. Yeah, sorry. And boom, I was done. So option 2 is second calc. This is not different. It's a different way to get the same thing. Second calc, and then dy dx, and then you can type in whatever value of x you like.
See, my question would be great.
So, which one's easier? I don't know. I would say one advantage of doing it on the graph. It's kind of weird looking. One advantage of doing it on the graph is that, it puts the spot on there, and you can sort of visually see, let's see, the slope is 1, that looks right, that looks like a slope of 1. I mean, it's not negative, it's not super steep. So those are the two options. Again, you can look at it on the graph. The downside to the graph is, I think you have to be on the graph to get an answer. So if I want dy dx at something that's off the graph, it won't do it. So your graph has to show the point you want a derivative of. Let's do number 4. Or are we ready to go on to number 4? Ask it that way.
Yes.
Wait, we don't have to do product, right?
So you have to put in the y equals for the...
Wait, you gotta clear the calc.
Okay. Well, you don't have to do y equals. You can do the math 8 thing and then type in the equation right there. So rather than, if you don't like the y1, the vars thing, that's fine, but then you got to type in that whole equation right here. Sine of... Does that make sense, Justin?
Yeah.
So it kind of depends. If it's really ugly, I like to do y1. If it's kind of an easier one, then I just type it in. Right? If it was sine of x over 8, I would just type it in. But if it's really ugly, I'm going to y1 because I think it's a little easier to deal with it there. So why don't you try number 4? It's the same type question. Find the acceleration. Oops, not at 4, but at 2. It's number 4. It's the same thing. It's a different equation, different value. Actually, it's not even a different value. It's still 2. And again, some of you asked, if you have a calculator, that's all the work you have to show, but you definitely have to tell me that acceleration is v prime. I know the calculator can do v prime. All the AP teachers and graders know that the calculator can take a derivative. So you don't have to show that work, but you do have to tell me you're taking a derivative.
Wait, what is the unit of measure on 3?
Sorry, that was a good question. What's the unit of measure for 3?
Feet per minute squared?
Yep, feet per minute squared.
Basically, plug in everything in y equals, and you just split.
All right, how do I know if speed is increasing or decreasing?
And you just scroll, and you can do a bunch of random stuff. So the easiest way to do y1 is just like alpha.
Careful, hold on. All right, listen up. Part B. Are we okay with part A? All the buttons? Okay, part B. Not okay with part A? Okay, let's back up then. So I typed it in for y1. Now again, if you already have it, if you already have a derivative typed in, you can just go get that one and do it again. But I'll start from scratch. Math 8 is my derivative.
Did you have that as e to the x in the y1?
Okay, so I'm using x because I'm in a y equals f of x thing. And I'll just replace the t with x's. So math 8, derivative with respect to x of y1. So then I got to go find my y variable. So as long as I remember it's a variable, I can get there. Y bars, the function, y1, when x is 2, 0.093.
Wait, is it the same equation even though it's speed?
Okay, that's still part A. Sorry.
Oh, my fault.
Thank you. Okay, so the speed. How do I know if speed is increasing or decreasing?
Positive.
This is what, positive or negative? I have to check velocity and acceleration. So I need to find V of 2 and A of 2 and then see if they have the same signs. I just found A of 2, so that one's easy. So increasing means same sign, decreasing means different signs. How can I find V of 2? When you say put it in the calculator, be more specific.
Type it in the thing and then put in 2.
Oh, okay, so you want to retype that whole equation and put 2 in for t?
Yes.
You could. Your calculator understands function notation, though? So I can ask my calculator to do y1 of 2, and it will do that. So vars, y1, at 2. So rather than have to retype in all of the natural log of the inverse tangent of e to the, I can just type in y1 of 2, and the calculator knows what I'm asking for. There's also ways to do it on the graph as well. Okay, so what's my answer here? Are we speeding up or slowing down? And how did you know that? A and V, same sign. If they were both negative, they would still be speeding up. You would just be speeding up in the backwards direction. Correct. Because to find if speed is increasing or decreasing, I have to know velocity and acceleration. Velocity is what they gave me, so I don't need a derivative. I just need to plug in 2. And you can plug in 2 like McKenna said, like type in the whole thing with a 2 in there. Or you can plug in 2 like I did, which is the better way, with the function notation. I'm calling her out. She's not listening. All right, question C. Find the time t greater than 0 at which the particle is farthest to the left. Justify your answer. maybe let's draw a picture of what it would look like to go farthest to the left. Something like that. It was going this way and then it switched around. What happened at that spot in terms of V's? And what happened in terms of V? Let's go with that first. V equals 0, and then more specifically, that's right, but then changes, and be more specific, which way did it change? V changed negative to positive, right? Because it was moving left, and then it turned around and started moving right. So now I know what I'm looking for. I need to look on my graph, because they gave me a graph of V, or they gave me an equation of V, and I want to know where V changes from negative to positive. And if it happens a bunch of times, then this is going to be tricky, but hopefully it doesn't happen too often. Let's see, I don't know how far out to go. Let's see. Oh, this is good. It changes from negative to positive one time. Right? I don't even care about what's happening on the left here. I need to zoom in a little bit, and at that spot, V changed from negative to positive right there. So I need to figure out where that is. Second Calc gives me lots of information. I want to find that 0. So second Calc. Second Calc 0. If you make it that far, it walks you through what it wants. Left bound. What do you think it means when it says left bound? Get to the left of the 0. And you can get as far left as you want, but if you want to be kind to your calculator and to yourself, if you get just left of it, it'll get there a little quicker. Right? If you give it a window this far to search, it'll find it, but it'll find it a little bit quicker if you narrow down that window. So, I mean, find it quicker. We're talking like tenths of a second. It's not that big a deal. Enter right bound, so get to the right of the 0. And again, you can go as far right as you want to go, but just get a little bit to the right. Guess, kind of the same thing. If you guess it, the closer you guess, the quicker it gets your answer. But quicker by tenths of seconds, not anything more than that. So you don't have to be fishing around to try to get it exactly. So that happened at t equals 0.443. So the calculator part uses the same concepts. Now you get to use your calculator to find the answers. All right. Today's assignment is worksheet 3. Tomorrow we'll work some from worksheet 3. We're done with notes. Monday we'll work some from the review worksheet. And then we'll test on next Wednesday, Thursday. And I would remind you that the stuff in Schoology, or the videos,